So now, as a cousin to the 30, 60, 90 right triangle, is a 45, 45, 90 right triangle. And we're going to use that to find cosine of 45 and sine of 45. Now, a 30, 60, 90 was half of an equilateral triangle. Okay, so that was our 30, 60, 90 right there. A 45, 45, 90, I want you to think about that as half of a square. Okay, so if I look at this thing here in the bottom, and I say this square has side length 1, okay, then what is the side length of the hypotenuse? This thing right here.
1 squared plus 1 squared, so the square root of 2.
There we go. All right, so this one's actually a little bit easier, I think. Okay? I think so. I don't know. But now, that doesn't help us for sine and cosine because the length of the hypotenuse here isn't 1. The length is root 2. But we can do this. We can say, all right, let's zoom in here. And let's give a name to this. Let's call this angle here is 45, right? Well, maybe I should write a thicker. 45 degrees, right? Okay, so maybe this is not the best color. All right, remember this thing, SOHCAHTOA?
SOHCAHTOA. Sine opposite of hypotenuse. What was it? Cos, right? Cosine adjacent to hypotenuse.
Okay, good. So sine is opposite over hypotenuse. Okay, so the opposite here to the angle is going to be the green.
Okay.
Okay, and the hypotenuse is the red. So opposite, and then hypotenuse is red. Okay, and then let's come up with a good color for adjacent.
Purple.
Purple. The adjacent is going to be purple. Okay, and of course hypotenuse is still red. And this is all relative to this angle down here, this blue angle, right? Okay, so with all that fancy color coding, now we can write sine 45 equals, well, what's the opposite? How long is it?
Sine 45.
Well, how long? So what I'm writing now is I'm writing the opposite and the hypotenuse. How long is the opposite in this picture? I'm circling it with the pointer.
1.
1, okay. And how long is the hypotenuse?
Square root of 2.
Square root of 2. Now, there's this little trick, which you may know from algebra or may not. We don't like to have radicals in the denominator.
No. So you have to multiply by the radical again.
Oh, okay. So you are totally up to speed on that. Okay. Sine of 45, root 2 over 2.
We keep running into that number. Where's that root 3 over 2?
Root 3 over 2 is the other one.
I know, but those two are very similar.
Cosine of 45. What is the adjacent? How long is it?
1.
1. And the hypotenuse is still...
Square root of 2.
Okay. And then I'm going to correct that with my same little thing. And of course I'll get root 2 over 2 again. Now cosine of 45 and sine of 45 are exactly the same. That should not be surprising because this is isosceles.
Will they always be the same? No.
Well, they're the same when the angle is 45 degrees because the triangle is isosceles.
Okay.
Okay, so now, back to the unit circle. Now our unit circle picture that we're about to draw 45, 45, 90, right triangle. Now, though, the hypotenuse is 1. Okay? But that's okay because we actually know that whatever these coordinates are, they are cosine of 45 degrees, comma, sine. of 45 degrees. And we just figured out what cosine of 45 degrees was. What was it? You remember?
Cosine? Yeah, square root of 2 over 2.
Okay, so this side is root 2 over 2, and of course this side is root 2 over 2. Okay? And you can also say to yourself, just like we did with the 30, 60, 90, there are other 45, 45, 90 right triangles all over the place. There's one. There's one. And there's one. Okay? So this angle right here would be what? 135? Because it's 90 plus 45. This angle would be negative 45. And over here would be negative 135.
Okay.
Okay? So this is enough. If you know about 45, 45, 90, you know about all 4 of these points
Okay.
on the unit circle.
Okay.
Okay? And like we did before, 30, 60, 90 tells you about all these blue points that I'm drawing. Okay? Now remember I gave you like a blank unit circle a long time ago?
That was a long,
Yeah.
long. There we go. We'll get fish 3.
Okay, so the point between these 3 videos that we've done today is enough to fill out that whole blank unit circle. Okay? All right. So that's enough for this video.